Hello, everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to be going over another problem in which you are using radioactive decay kinetics to solve a problem. In this problem, we're going to be using the percent rate decay. So here in this problem, we're told that a researcher claims that an ancient scroll that originated from Greek scholars in about 500 BC. We're told that the C14 decay rate of the scroll is only 89% of that found in living organisms. So instead of being 100%, it's decreased to an 89% over a certain period of time. So our job is to figure out how much time has elapsed to allow for that decrease in 89% for the decay rate. And so we need to figure out how old this scroll is and whether or not it's authentic. So here, in my last video, I showed that if you're given decay rates, don't fear because the decay rates are related to the amount of substance you have at a particular time. So the rate at which something decays at the initial time is equal to k multiplied by the initial amount you have. And then the rate at any future time t is going to be equal to k times whatever amount you have at time t later on. And so if you divide these rate laws, the rate constant cancels out, and you basically get the fraction or ratio of rates is equal to the ratio of amounts. And since we have this equation here that has a ratio of amounts, then we can substitute in this ratio of rates for the ratio of amounts. So then, or we can, the other way around, we could substitute in the ratio of amounts for the ratio of rates here. And so we get this equation here. And so now we can use rates to then solve our problems. But here we're not given a fraction, we're given a percentage. But don't worry, because as I pointed out, here we have the fractional amount that's left after a period of time. Well, if we multiply this by 100, like I do here, then you get the percent that's left. But that percent that's left is also the same as the percent rate that's left, the decay rate, the percent of the decay rate that's left after a period of time. Sorry about that. Okay, so since we're given a percentage, we can then use this equation here as a percentage as well. So then this then becomes the percent that's left. That could be the percent, the percent that's left, the percent decay rate that's left as well. So this could represent the amount that's left or whatever the decay rate, the percent of the decay rate that's left. So then all we need to do is figure out the stuff that we need to plug into our equation. So here we're given the percent left, so that's going to be 89%. So 89% is equal to, and then we have 1/2, and then that's raised to the power of t over the half-life, t 1/2. And that's going to be multiplied by 100. So that's our equation. So we know the half-life because we're dealing with carbon-14. So the half-life of carbon-14, t 1/2, is equal to 5,715 years. So we could plug that into here. So then that's going to be 89% is equal to 1/2 raised to the power of t over the half-life. And I was about to write t 1/2 again. So that half-life is 5,715 years. And then this is multiplied by 100. So what I want to do is I'm going to divide both sides by 100 to get rid of the 100. If I divide that, then this becomes 0.89, which is now the fractional amount. Now I'm back to this fractional amount or this fractional amount, right? And that's going to be equal to 1/2. Let me bring this down so I'm not bumping into myself here. So this is going to be 0.89 is equal to 1/2 raised to the power of t over 5,715 years. And now I want to take the log of both sides because I want to get this power down here. So now I'm going to take the log of 0.89, and that's going to be equal to the log of 1/2 raised to the power of t over 5,715 years. Now, because of the law of logs, I can take the power here and put it in front of the log, and that will give me the log of 0.89 is equal to t over 5,715 years multiplied by the log of 1/2. Now I can divide both sides by the log of 1/2. Divide this by the log of 1/2. So this cancels out. Now I have these two equal. So I'm going to figure what that is. So I'll go ahead and calculate that out right now. So that's going to be, if I take 0.89 and then take the log of that and divide that by the log of 1/2, and I get, and I'm going to write it over here. So I'm going to move over here. I got 0.1681. So 0.1681 is equal to t over 5,715 years. So now all I need to do is multiply both sides by 5,715 years. So multiply this by 5,715 years, multiply this by 5,715 years. This cancels out, and I get t is equal to whatever that is. Let me go ahead and calculate that out. So multiply that by 5,715 years, and that gives me 960.8. So 960.8 years. So that tells me that this scroll is 961 years old. If I go back 960.8 years from today, that's going to be about the 1100s, right? Or maybe the 1000s, like somewhere in between 1100 AD and 1100 and 1000 AD. Definitely not close to the claim that it was originated in 500 BC. So this is likely not to be authentic at all. Okay, so that's how you're able to do these sorts of problems. I hope this was helpful and insightful and exciting and entertaining as you would like it to be. So if so, then please like my videos, share my videos with other people. Also, click that like button over there. Also, you want to subscribe to my channel, hit the notification bell somewhere over there somewhere. And when you do that, make sure you click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.